not ready for that technology.
Not ready for that. I don't even have like a Facebook account, so I'm
There's
just
like
not
YouTube
there.
videos of people who stream and constantly make those mistakes.
Yeah. Nice. All right. So before I go through the stuff that I want to talk about, questions from you on PA1 ODPs, things like that, whatever. Or I can talk about what I'm talking about, and you can ask questions along the way, or after, or in between, or whatever. Yes.
So for the Sentinel node, I just set the data to the -9999.
Okay, good.
Is that what you wanted, or is there some other way to make sure they can't get rid of it or override it?
Unless mentioned otherwise, I nor anything is ever going to look at the data field in the Sentinel.
Okay.
So you don't even need to initialize it. But it's nice to give it a particular value like that, so that as you're writing your code, if you print your list and you see that value coming out, it tells you right away, hey, I'm not ignoring the Sentinel where I should be, right? So that's a good practice.
Could I just do an if statement to make it, if someone does enter that -5 nines, it just tells them it already exists?
No, that's a valid number to enter in your data.
Okay, but it already exists. So
But it doesn't exist in a data node, it only exists in the Sentinel.
Okay.
And the trick is when you search for a node, don't check the data value in the Sentinel. Start with the node the Sentinel points to. Check that data value, check the next node's value, and so on. Always start with the thing that it points to, the first data node. And if the Sentinel doesn't point to anything, if its pointer is null, there's nothing in the list. You don't have to search. Mm-hmm.
Can we maybe briefly go over how you go about to point to the new node if you're deleting a number?
Sure. So let's look at algorithms. So here's a Sentinel. And let's just make a list of 3 data nodes. And let's just store 5, 10, and 15 as our data values. And this last node, the next pointer is null. That's the end of the list. And let's suppose this is stored in an array of struct nodes called LL. And so each node has 3 fields. There's a data field, there's a next field, and there's a valid field. We don't know what this array looks like just from looking at this linked list. There's a lot of different arrays that will correspond to this linked list. But let's just work with the most straightforward one. Assuming you built this list, you started with a 5 and a 10 and a 15. Here's what this is probably going to look like. So I'm throwing a 42 in my Sentinel. It's valid. The first data node will probably be stored at index 1. So the Sentinel will point to index 1. At index 1 we find a 5. It's valid. Let's say this node is stored at index 2. And at index 2 we have the third node with a value of 10. And it's valid. And it points to the third node, which is at index 3, which has a 15, is valid, and has a next field of -1. I asked this in the other class. Let me ask it here. Is everybody comfortable and clear on what I mean when I use the word index? Right? Index is the value in the brackets of the array, right? The index of this node right here is 3. The index of the Sentinel is 0. Okay, so when I say this thing has a next field of 2, that's the index of the next node. I mean the next node is at LL bracket 2. Okay, that's the way that we're linking these nodes together. All right, so here's an array that corresponds to this list. And let's say we want to delete the 10. So we're going to do this with a pair of pointers, right, indices into our list. We're going to always need to know the node before the node that we want to delete. when we get to the point where we're ready to delete the 10, we're going to have to do something with this node that has a 5. We're going to have to make it skip over the 10 and point to the 15. So as we're moving through the list, we always want to keep track of the previous node we were at. And the first node we want to consider is not the sentinel, but the thing pointed to by the sentinel. So we're going to have a pair of indices, starting with the first one being the sentinel and the second one being the thing that it points to. All right, so let's make a pair of these nodes. So let's have previous equals 0, and let's have current equal LL previous is next field. Okay, previous is 0, that's the sentinel. Current is whatever this thing is pointing to, LL0.next, which is going to be a 1. So here's the current setup. This is previous, and this is next. And so at this point, we can say, do we want to delete this node here at next? And we don't. So we need to move down the list. So let's say if LL next dot data equals 10, use a variable, right? If it's equal to 10, then we're going to do something, and we're going to return. Otherwise, what we need to do is move down one spot. We want to change it so that this is previous and this is next. Okay, it takes 2 statements to do that. So we can set previous equal to what next is. So that'll make previous here. And then next should be whatever next is pointing to, which means look at that struct node and look at its next field.
Can't see the bottom.
Ooh. Okay, look at that struct node and see what it's pointing to. And so if we do that, then next will change to LL next dot next. It'll change to this node right here. So next will be this node. And we're in exactly the same situation we were at the beginning of this. We're considering this node for deletion, and we also have our handle on what the previous node was. So now we say, is LL next data equal to 10? And the answer is yes. Okay, so here we want to delete the node named next. So how do we do that? Well, what we want is we want this previous node, instead of pointing to next, to point to the node after next. So LL previous dot next equals, and it should simply be whatever the next node was pointing to, which is just LL next dot next. And once you do that, this is now pointing to the 15. We remove the 10 from the list.
Would be the next for the current one?
Say again?
What would be the next value for the current?
Oh, I switched to using cur, yeah.
Oh, that makes more sense.
I was trying to use previous and current, but I switched to previous and next. Alright, so previous is the node before the one we're considering, next is the node that we're currently considering. And then we need to release this node, so release next, which sets the valid flag back to 0 so that that spot in your array is available. And so all of this goes inside a loop. Now, if you searched ahead of time to make sure the thing you're trying to delete is in the list, you know that eventually this if condition will be true. And you could put this in an infinite loop safely. But if you don't do that check first, you need to have something in here so that if you get to the end of the list, you kick out of the loop. So you could do while next is not equal to my null, would probably work. But like I say, the easiest thing to do is just search before you delete. And then you know that it's in the list somewhere and you'll eventually encounter it.
So in setting next does not equal my null, that one, wouldn't it stop execution before checking the last thing on the list to see if that's the one that needed to be deleted?
So
Like if you wanted to delete the data 15.
if I were to up here say while next is not equal to my null, then when next is pointing to this node, it's not my null, right?
Yeah.
So it would go ahead and it would check the 15 and delete that. But if it doesn't find the 15, it's going to say next equals this thing's next field, which is my null. Go back to the top of the loop. Now it's going to kick out. Edge cases are always tricky, right? So you got to ask exactly those questions and then work through them. And it's pretty easy to be off by one. Either miss the last node or not stop soon enough and you seg fault.
Yeah,
So.
I did that last night. I was like using my fingers to like do 3 things.
Mm-hmm.
I need a third hand.
Yeah, you need an octopus friend. Cool.
GDB was actually pretty helpful for finding it didn't help at all for seg faults, but it helped if you stopped one short.
Right.
Infinite loop or something.
Okay, cool.
Whatever reason, when it seg faulted, I couldn't find where it was doing it using GDB because I'd step and it would automatically seg fault
Okay.
or something.
So the thing to do there is probably to get up to the point right before it's going to seg fault. Look at that instruction and then print out the different pieces of it. So if it's something like next equals ll bracket next dot next, right? Print out the value of next, print out the value of ll bracket next, and see what next is equal to, and so on. And we're going to run through some of the stuff, and we'll run through the ODP and GDB in a little bit. And so we'll see some ways to use that. Now, deletes are a fun function to write because there aren't a whole lot of special cases. So suppose this is what our list looks like and we want to delete the first node in the list. Well, the way that we've been doing this, we're starting off, this is previous, and this is next. And our code was to say ll previous dot next equals ll next dot next. That was what actually removed it from the list. That's going to work exactly the same in this case where we're deleting the first node, because ll previous dot next is going to be set equal to whatever this thing was pointing to. That's going to have the effect of changing the sentinel to point what was the second node. And we've removed the 10 from the list. So because we have this sentinel, deleting the first node in the list is no different from deleting any other node in the list. So one possible exception is when we're deleting the last node in the list. So we're deleting 40, and we're going to get up to a point where this is previous, and this is next. But what are we going to do here? We're going to set ll previous next, that's this right here, to be equal to LL bracket next dot next, that's my null. This is going to put a my null right here, which effectively removes this node from the list. Because as we're following the list, once we get to this node, we're going to say that's the end of the list. So first node, last node, middle node, exact same code. Right? So that's a nice feature. You don't usually get that with these things. But the case of the first node, that's what the Sentinel helps us with.
You said that you want us to use a release function instead of in the delete function, making the valid, what was it, 1 or 0 rather?
Yeah, so call this release node with just the index of the node that you deleted. And the only thing that does is set the valid flag to 0. But I want you to put it in a separate function. The reason being that when we do this in PA2, we're not going to store our linked list in an array, we're going to store it in just bare memory. Oh, there's my face again. That's no good. There we go. We're going to store it in memory, right? And when we want to create a new node, we're going to ask the operating system to give us some memory using malloc. And when we delete a node, we want to return that memory to the pool of memory to the heap, and we do that by calling free. So it'll be a function call to create a node, but also a function call to release a node. So that's why I'm having you do that release. All right, does that help with delete? Okay. My recommendation is do print first, and then do search, and then do delete, and then do add. That would be increasing order of complexity. But if you can do print, right, you figured out how to move down the list, how to follow the chain of pointers. That's half the work right there, right? It's only a couple of lines of code, but conceptually that's half the challenge, is being able to follow the pointers from one node to the next. And then if you can, search is the same as print, right? Instead of printing, you just compare the number to the thing you're looking for, compare the node's data value to what you're looking for, and if you find it, return a 1, or whatever you're returning. And then delete gets you moving down in pairs where you're keeping track of the previous one, and then add is almost the same thing as delete, except instead of making that particular pointer adjustment, you make a slightly different one, which is, let's say we want to insert between here and here. So you make a new node, you store the data value, you take this node's next and you set it equal to the previous node's next, right? So that this actually points up here, and then you take the previous node's next and point to your new node, and you've inserted. So it's 2 steps instead of 1 for delete, but almost the same thing. The other wrinkle with inserting, with adding, is you're trying to keep the list in order. So if your list contains these nodes, and you want to insert a 25, you move down in pairs, you stop when the next node is bigger than the number you're inserting. Right? As soon as that happens, you know you're inserting between the previous and the next. And if you've got a previous variable and you've got a next variable, it's 2 lines of code to do this arrow adjustment, right? So that's the other trick for insert. So let me make a few other comments. And then let's look at the ODP and look at some GDB and some main code and build some linked lists in memory. Oh, did anyone here leave a coffee mug in here after the first class? Good light. I noticed it sitting on a table at the end of this section of 222, the first or second class. All right, so let's talk about tar files, okay, briefly. So let's say this is what's in your directory. This is your final project. You've got a main program and you've got a function called getFirst, and you want to turn this in. Okay, you're also going to have a Makefile. I don't have a Makefile in here. I'll make a Makefile. It's bogus, but I've got a Makefile in here. And you want to put this into a tar file to upload to Canvas. Okay, here's the best way to do this. Tar cvf pa1.tar, and then the stuff that you want to include. Okay, mymain.c, getFirst.c, Makefile. And it will show you each thing that it's adding into your archive. And if you want to double check what's in your archive, you can say tar tvf for table of contents, pa1.tar, and it shows you mymain.c, getFirst.c, Makefile. Okay, that's something like what your tar file should look like. Let me touch on two things that can go slightly wrong. One is doing this. Right, building a tar file and including subdirectories in it. Okay, I'm asking you not to do that for these assignments. Because now, if I look at pa1.tar, it's got your files sitting underneath a subdirectory, in this case called work. Okay, it's not the end of the world, but it means that if I download your tar file and I say tar xvf, your code is not sitting in my directory, it's sitting in a subdirectory. And I need to go into that subdirectory, I need to move all those files back up into my main area, and then I need to delete that directory in order to run my test scripts and such. It's not a big deal, okay? And in some cases, this would be the right thing to do so that it automatically puts into a subdirectory. But for the PAs in this class, I'm going to ask you to build the tar file from the directory that your files are in. Okay, so that when you extract it, it just dumps the files into the current directory. That's the first thing. The other thing is, if you just say something like tar cvf pa1.tar star, right? I've also included my executable program in here, my main. And if I've got .o files, those will get included also. And the downside of that is if I say make, it's probably going to tell me everything's up to date. And if you put a clean option in your make file, I can say make clean and then make. But if you didn't, I have to go through and I have to manually delete your executables and your .os in order to recompile it. Okay, so in general, when you're making a make file and you're putting it inside, when you're making a project and you're putting it in a tar file to push out to the world, what people want to download is source code, make files, documentation files, text files, things like that, but not the stuff that you have already compiled. Right? Because you might be compiling on an x86 architecture, somebody else might be trying to run your code on an ARM processor. And they should be able to download your tar, extract the files and say make, and it will recompile using the GCC that's running on their processor, which will give them objects and executables that will run on their processor. But if you already include those, right, then they have to go through this cleanup step. So in general, when you're making something that other people are going to look at, like me, right, you only want to include source files, .c, .h, things like that. Text files, documentation, and a make file. Okay. If you're in doubt, I'd rather you put in more than less, right? Don't take a chance. If you're not sure what you're doing, don't accidentally send me your thing without your main program in it, okay? Because that's no good. But it's cleanest to not include the .os and the executable. So that's a pretty minor thing, but I wanted to mention that more for down the road. Talk about .h files. So here's my main, and I've got a struct node statement at the top. And here's my get first, and I've also got a struct node statement at the top. And if you're breaking your program into 5 or 6 files, chances are each one of those is going to have the same set of statements in the top to define a struct node. And if one of them accidentally says next data valid instead of data next valid, your code's not going to work right. And it's going to be a real pain to debug, because you're going to look at this and you're just going to see I got my structure defined. Or if you decide you're going to change this structure, and you've got these statements in 6 different files, you got to change it in every one of those files. So this would be a perfect example of something you could throw into a .h file. So I could do put this into a .h, and I could say number include node.h. And now I'm pulling in that same set of statements by doing this include statement, and node.h just contains my struct node.
Can you put the include standard IO in this part and not in the other files?
You could, but that'd be probably not best form. Why? Because if you decide to get rid of this, you'd accidentally get rid of standard IO.h also.
Mm-hmm.
But yeah, functionally it would do exactly the same thing, as long as you're including this everywhere that you need stdio.h. And this define my null, that doesn't have to be in here either. I could go ahead and put that in here also. And now my code looks a little cleaner, right? Here's my function, and I have a single include node.h. I don't have to look at this ugly fact that my null is defined to be a -1, right? I don't care about that. I'm only using the value my null. I'm never saying -1. Why should I have to look at the fact that my null is defined to -1, right? So this is a little cleaner looking. And my main program, same way, but down here in this include file, that's where I've got all these gory details. And if I decide I want my null to be -2, I can just change it here, recompile, all my code should still work. So there's a federal ban on using -1 in C code suddenly. I can change one file and we're good to go.
Could happen.
What you don't want to do though is put executable code inside here. So suppose I have a print routine for printing a linked list. I wouldn't put the code for print inside this .h. Right? That's not really the purpose of a .h file. A .h file is to prototype functions, define symbols, define structures, things like that. In fact, this prototype down here probably belongs in a .h. Because if I have several pieces of code that use this function, by simply including no.h, they're all going to have this prototype. And if you don't use this function, you can still prototype it. It does no harm.
Doesn't hurt to prototype the function in which you are working in?
Shouldn't hurt it, no.
Okay.
But if I put the print function in here, if I actually write the code for the code that's going to print a linked list, right? Then if I include this file in 2 different pieces of code, I've got 2 pieces of code that effectively define a function with the same name. And when I compile, I'm going to get link errors. It's going to say redundant definition. So let's compile this cleanly first of all. Right, so that's a nice clean compile. Suppose I do this. I don't know if it'll complain if I don't actually use this function, but here I'm writing a function and I'm putting it in my .h. When I try to compile, it tells me it's got multiple definitions of fun. Why is that? Because inside my main.c, I'm including no.h, which means I'm defining what the function fun does. And inside getFirst.c, I'm including no.h. And in there, I'm defining what the function fun.c does. And it's just like writing a program where you define a function twice. It's a compile error. It's actually a link error. Because it doesn't know which function is the real function fun. Right? So we don't usually put executable code in here. Prototypes define structures, other things like that. Does that make sense? So let's make a Makefile. So Makefile, I want to build a main program. I'll just call it my main, since I already started with that. So name of the target followed by a colon, followed by a list of dependencies, things that need to exist and be up to date in order to build this. Well, I have two direct dependencies for this. I have myMain.o and I have getFirst.o. So remember, if you compile with a -c switch, it doesn't build an executable. It just compiles the C code into binary, and it leaves it in the form of what's called an object file. That's a .o file. So if I have both of my objects, myMain and getFirst, I can link those together using GCC to build an executable. So you start your recipe with a tab, and you type in your command for building that. So if I say make, what the system's going to do is look to see if I have a myMain that's more recent than both myMain.o and getFirst.o. And if it is, it'll say my main's up to date. But if one of these is more recent, it's going to say, okay, I need to rebuild my main, and the second line tells it how to do that, and it'll execute this GCC command to link those two objects together, give me an executable. Well, if my main.o doesn't exist, it's going to look for a recipe to build that. So I can give it a recipe, my main.o, and I tell it what pieces it needs to make that. Well, I need two pieces. I need myMain.c, and I also need node.h. And if both of those exist, I'll gcc-c myMain.c. I don't compile node.h though, right? It's not a file that we're feeding to GCC. It's a file that's being included inside myMain.c. So if I say gcc myMain.c, the first thing it's going to do, one of the first things, is find the code for node.h and include that in the file myMain.c. So it'll get compiled inside myMain.c. I don't list it after here. I don't think it'll do anything bad if you do, but it's not technically correct. All right, getFirst.o depends on getFirst.c, and it also depends on node.h. And if that exists, I can say gcc-c getFirst.c. So there's a 3-recipe Makefile for making my main program. And if I say make, it's going to do everything. It's going to compile my main, it's going to compile getFirst, and then it's going to link them together into my main. And if I say make again, it's going to tell me my main's already up to date. If I change getFirst and I say make, it'll recompile getFirst and then it will link everything together, but it did not recompile my main. Right? The reason it knew not to recompile my main is because of the Makefile. myMain.o was already up to date, right? It only depends on myMain.c and node.h, and none of those had changed. So my main.o is up to date, but getFirst.o depends on getFirst.c, which had changed. It had a more recent change date than the .o file, so it rebuilt getFirst, and then after doing that, it went ahead and built my main.
So how would you write the target if like get first called another function?
If it calls another function, that's not really in the make file. Okay, so the make file, we're really looking at what do we need to compile in this case, right? So suppose the main called get first and release node and delete and add and all these other things. If those were all in separate files, I would list all of those .o files right here. And then I have a recipe for building each of those. Add.o comes from add.c and node.h and so on. But if getFirst depended on release node and that was in a separate file, right, then release node.c would be a dependency for getFirst.o, right, and I would need to include well, we probably wouldn't encounter that. But yeah, let's see if getFirst needs release node. No, but it's not dependent on it, right? Because if release node changes, we still don't have to recompile getFirst, right? So here's a function, it's calling another function. If the code for this changes, we don't need to compile the code for this. We need to relink, right? But this has to get recompiled, this does not, right? It's exactly the same case as where we're changing getFirst. Yeah, so the .o's are just compiled versions. They don't actually contain the code for what you're calling. Now, if the prototype changes, right, then we're going to have to change the prototype inside getFirst, and then that would cause getFirst to get recompiled. But the reason we prototype is because when you compile down to an object module, it doesn't actually contain the thing that you're calling. It's got basically a holding place that says, okay, here's where I'm going to call this function, this is what I'm going to pass, this is what's going to come back. And that function could change into something totally different, but as long as the interface, the argument list, and the return value are the same, this object's not going to change. Alright, so if I say make, it tells me everything's up to date. Now if I change node.h and I say make, it's going to compile both my main and getFirst because both of those include main.h, right? So I listed it as a dependency. And since main.h changed, the actual code inside my main.c is effectively changing. And so that has to be recompiled. And the same with getFirst. And then if you say make again, it should be up to date. So Makefile's handy as you're doing this. It stops you from having to worry about these things, assuming your Makefile's correct. If your Makefile's not correct, it can really ruin your day because you end up trying to fix a bug and you keep changing it and remaking and it doesn't seem to be making any difference. Well, if that happens 2 or 3 times, go back and look at the dates on the files. Make sure you're actually recompiling because I can't tell you how many times I've done that. I'm chasing a bug and I'll spend an hour trying different things and it turns out the first thing I tried would have worked, but I didn't actually recompile the code. And so I just kept testing the same executable program and I had the same error again and again. It's really annoying.
I had that error last night.
Did you? Oh, I'm sorry.
I
should have mentioned this earlier.
Why isn't this flow working?
Yeah.
Why isn't this ODP
Yep.
working?
It's really frustrating, but after you've done that like 4 or 5 times, you start to think of that more quickly.
Yeah.
So, but it still catches me once in a while. All right, so Makefile. So you need a Makefile for PA1. Yeah.
What would in your Makefile, could you do like clean?
Yeah. So. So here I'm telling it that there's a target called clean, and this doesn't actually create a file named clean. It's bogus, okay? Having a target named my main, my recipe actually creates a file called my main. Having a target mymain.o, my recipe actually creates a file named mymain.o. That's not what happens here. My recipe is not going to create a file named clean. I'm using this to trick the make system into doing something I wanted to do. So if I say make clean, it will say, okay, there's no dependencies. How do I build clean? I execute this command. Remove mymain.o, get first.o. And so if I say make clean, it'll get rid of my objects for me. All right, so to remove those two files. If I wanted, I could make a target called joke. And if I say make joke, it'll tell me a riddle. So why do cows have bells? Why do cows have bells? Because their horns don't work. Sorry. I was playing around with Google. I said, tell me a joke. That's a joke it told me. Yeah.
So if you do a make clean, will it go on and do the joke?
No. Now, if I listed that as some kind of dependency on making clean, then I could probably get it to do that. But if I say make clean, it's really just looking for a formula for clean. Whoa, that was interesting. Oh, but I can't remove those because they don't exist. But that's okay. But if I make my file, then I make clean. So there's no sort of sequential execution here like we have with a regular program. It's really, if I say make my main, it'll look for a list of dependencies for my main and then execute the recipe. And everything else is dependent. But if I just say make, it always builds the first target, which in this case is my main.
Did you put C code in there and make it just execute a whole programming type joke? Or?
You can put bash code in there, or you could put a compiled C program, sure. Or you could put a make command and get yourself in an infinite loop. Yeah, you can do anything. This is why it's a little scary when you download code and it's got a make file and you just say make. It could be doing anything. So you really don't want to do that unless you really trust the source or you've looked at the make file. Right?
I've made that mistake a lot. I'm lucky, I guess.
Really? Okay.
I didn't know it could do whatever.
Yeah, it can do whatever. It can do rm-rf tilde. Right? And there you go.
What kind of jerk could do that?
Yeah.
White House.
Yeah, right. All right, so let's take a 5-minute break. And then I want to talk about the ODP that we just finished, and I want to look at it in GDB and look at making some test code. And then we'll go ahead and talk some more about PA1, then I'll introduce you to PA2, which you can start on Friday, unless you've already done PA1.